Okay, college algebra. We're going to look at the sum formulas for sine and the sum formula for cosine right now. All right. You don't need to memorize these formulas. You can always use this cheat sheet for all my exams. You do need to know how to use these. So the directions are going to be find an exact value. And then when we're going to look in here, we're going to look at 11 pi over 12, and I can't find an exact value for that. I can't make a triangle. I can't find it on the graph. So what we have to be able to do is think of it as one of these sine formulas where we're thinking of an angle plus an angle that would add up to 11 pi over 12. Okay. So what we got is we know we have this common denominator of 12. So we know that we got a common denominator of 12 here. We just got to figure out how it's going to add up to 8 or how it's going to add up to 11 in a way that I can simplify these to make something that I'm more used to, right? I would like this to be something I'm more used to and something a little more simplified. So I want to make it two angles that are easier. So 8 plus 3 adds up to that. So I'm going to put the 3 here and the 8 here. And when I simplify that down, well, 3 pi over 12 is just going to be pi over 4. So that's going to be this guy. And then this 8 pi over 12, well, that's just going to be this guy right here. And now what I have is I have an easier problem to use, okay? So now what I can do is use the right side of this equation. So see, I have sine of an angle plus an angle. So now I'm just going to call this angle U, this angle V, and then I'm going to write this. So sine of U, that's this guy, times the sine of V, so that's the other angle, times the sine of V, and then we're going to add the cosine of U, so the opposite one, and the sine of V times the sine of V. Of course, we can now evaluate those trig functions at that funky angle. So then when we do that, we're going to get, well, sine at pi over 4 is just root 2 over 2. Then we're going to get cosine here is just negative 1/2. So this is going to be times, this will be times negative 1/2. Okay. Then we're going to do cosine of pi over 4. And that's going to be, oh, whoops, not that one. That's going to be this guy again. So we'll make a copy of him. Okay. Then we get the sine at that weird spot, and that's root 3 over 2. So that's this guy. So times there. So then when we multiply straight across, this fraction just becomes this guy right here, just with a negative in front of it. And then we're going to be adding, multiply straight across right here to get this guy. And then we're going to get just one big fraction at that point, where we're going to have the numerator would be like root 6, take away root 2 all over 4. So that's our exact value. So cosine would work the same way. So down here I have an example of cosine. Well, 75 I don't have a good thing to solve for, but 30 plus 45 adds up to 75. So then I could use the right side of the cosine the same exact way. So we use this when we can't evaluate at a weird angle and we need an exact value. See my exact value, so it's always going to end up with some weird radicals. But what we're trying to do is find two angles that we can evaluate. So of course the only options are 30, 60, 45, 90, 180, 270, 360, right? The graphs and the triangles. So that's how we use the sum and the of both of these, the sum formulas of both of those, okay? Tangents the same exact way. It gets a little weird because we get this, the right side